So in this lesson, we're going to look at direct variations and the constant of proportionality. We want to be able to say is I can identify direct variations and determine the constant of proportionality. So hopefully in me modeling some of this, you'll better be able to do that. So in this situation, the distance, d, in miles a runner runs varies directly with the amount of time, or t, in hours spent running. Suppose Antonio's constant of proportionality is 9. So it's kind of giving us the constant of proportionality to start out with. Write an equation that represents the relationship between the distance ran and the time spent running. Assume the runner can maintain the same rate of running. It has to state this because, like, obviously when you're running, you get tired. But in terms of an equation, you're thinking in the form y equals k, being your constant of proportionality, right here. And that's going to be times x. But in this case, we're looking at that represents the relation between distance ran and time spent running. So we're looking at the variables d and t. And generally you're saying, okay, the distance that he runs is going to equal probably his 9 times t. So that's just because this is probably in miles per hour. It doesn't tell us. So if we said miles per hour and then figure out his hour, or if this is maybe 9 laps per minute, and then you figure out the time in minutes, however it is. Name the constant of proportionality and describe what it is in this problem situation. So it is 9, and it says this is miles is d, so I would guess that 9 is probably 9 would be your constant proportionality, and then you would say just name it and describe what it represents in this situation. So I would say 9 might be miles per hour. Although this here is probably not the best question because they don't tell you what this not like. It's like 9. Well, 9 what, right? All we know is distance in miles and time is in hours, so we know that's probably miles per hour is what 9 represents. Based on this, it's most likely what it is. So now you'd want to complete the table to show the amount of time spent running and the distance run using the equation we wrote. So we assume that his rate is constant. So again, we have distance equals 9 times t. So in this case, you'll plug in t, you'll get your distance. And so I can tell you real quick, this is going to be 0. And then you're like 0.25 times t. So you have to figure these out. I'm going to pause the video, figure them out, and fill it in. So you should pause the video too, figure these out, and then come back and check to see what I do when I resume. Alright, so I went through and figured all of this out and filled in the table, so it probably just popped up for you if you didn't pause. So sorry about that, but so what I did is I used this, and so for the first one I just multiplied my hours times my distance. Then I realized, like, wait a minute, this is twice this. So I realized I was actually counting by 0.25, so I just doubled this and doubled this. This gave me 4.5, this gave me 0.5, so I was able to fill in that blank. Then I added these two together, because 25 plus 50 hundredths equals 75 hundredths, and then I added these two together, 6.75, and then this I knew because this was 1 times this, so bam, that would help me fill in the 18 as well, and then I added 9 to here to get 11.25, because it was adding 1 to here, and then I added the 0.5, so I added this to 9, because I was adding this to 1, got to that, and then for the 2 I just multiplied by 2. Alright, let's keep moving on to the other parts. So this next part says, it says, as you know, when two quantities vary in such a way that the ratio of the quantities is constant, the two quantities are directly proportional. You can also determine if two quantities are directly proportional by analyzing the plotted points on a coordinate plane. And how you do that is you're looking for it to go through the origin. So you have to know 0, 0 is going to be 0. And I'm telling you right now, that is the case in this. So we're directly proportional. You need to go through the origin in order to be directly proportional. That's an important thing. And so graph the values in the table you completed on the coordinate plane shown. Graph the values on the values of t on the x-axis and the values of d on the y-axis. So I'm going to go back, look at the table, plot them on here, and you can come and compare them. Alright, so I didn't plot them all, but I got some of the major ones, like 2 and 18 and 1 and 9. Those are easy. And then some of them you had to estimate, like 0.5 and then 4.5, so I had to kind of estimate. But if you take a line and put it through there, So, and try and put it through at least the 18 and the 1 at 9. You can see that this straight line pretty much goes through there and the origin. So, when I come down to the next question, this is, what do you notice about the points on the graph? Well, they're all like in a straight line, and they're all like kind of the same like portion apart. Like if I go up, so they're all on the, I can say they're all on a straight line. And now this is where it talks about, would it make sense to connect the points in the graph? Why or why not? Is it discrete data, or is it continuous data? So I'm thinking, is this discrete where each thing kind of represents a number on its own and you don't have in-between values, or do you have? And I would say, like, yeah, we want to connect this. This is continuous. You can have partial miles and partial hours. So, for the purpose of what I'm looking at here, I think we could definitely connect this. Interpret the meaning of the point 0, 0 on the graph. So I just go back to like my axis. That means that in 0 hours, I would run 0 miles. That's all that means. And then interpret the meaning of the point 1.5 and 13.5 for the graph. So it's just the same thing. You're just filling in the blanks here. So that just means that in 1.5 hours, he would run 13.5 miles. Man, remember that the graph of two variables that are directly proportional will have, or that vary directly, is a line that passes through the origin. You need to go through the origin here. The final thing I want to add is, like I talked about back at the beginning, that you should be able to identify direct variations. So we know how to do that. You're looking at things that go through you're looking at data points where you have a constant proportionality, and the line that you might draw would go through the origin. Now, how do I figure out the constant proportionality? So they said it was 9. So like, how would I figure that out if all I had was the data? Well, what you do is you can come here, and you find like some easy points to count between. And so like from here, this one here at 1. So like what you're doing is, you can use the table, or you can use this, and you're basically saying, since it's proportional, you're saying y over x, or what is my change in y over my change in my x values. You're trying to see if these should be equal. So you come over here, you look at your x, and say my x is 1, right? Okay, and then over here, my x is 2. So I know the change in x is going to be 1 right here between these. So 1, and then my change in y. Well, how much did I go up? Right? I went over a total of 1. Right? How much did I go up? So I went from 9 up to 18. So I went up 9. So I do 9 over 1. And that's going to equal your constant of proportionality, which is exactly what we used in the equation when we multiplied by 9. So hopefully now you understand better how to calculate your constant proportionality and how to determine if a relationship is a direct variation.